is Roger Green, host of the Surfing the NASH Tsunami podcast. Today, we are offering 4 conversations from episode 39. Our discussion with Mazen Noureddin about his recently published paper discussing the new MASEF blood-based non-invasive test for fibrosis and fatty liver disease, the first test to take advantage of metabolomics in a potentially commercial setting. Mazen Noureddin starts this conversation by sharing information about the MASEF paper. He notes that the work goes back many, many years, at least 2015 for data collection and longer than that for basic study, and credits some of the researchers who played a major role in researching metabolomics and fatty liver disease. Before discussing the study itself, he then goes on to list co-authors on this project, including many of the world's most prestigious hepatology researchers, discusses its release, and the way he anticipates the test itself being used upon approval in the U.S. later this year or early next year. At that point, Jörn Schattenberg commends the study for the breadth of size, really, countries and global regions from which patients for the study were recruited. Mazen then goes on to explain why, within this broad study, researchers decided to exclude F4 patients from analysis. Finally, he dives into the results by sharing findings from Table 5 in the paper. Among other data, this table looks at the sensitivity, specificity, and indeterminate zone for Fib4 followed by MASEF versus Fib4 followed by transient elastography or even FAST. MASEF performs at least as well as the other tests and perhaps slightly, although not significantly better, even though it is blood-based and the previous regimen includes imaging as well. This is important because as a solely blood-based marker, MASEF is more convenient to administer and presumably less expensive over time than the Fib4 transient elastography combination. NITs, and particularly blood-based NITs, are an important area for academic and commercial development. This conversation introduces an exciting new blood-based NIT that brings metabolomics into the discussion for the first time, and it provides an enticing glimpse of what our future might hold. So sit back, listen, learn, enjoy, and when you're done, join the dialogue on our LinkedIn discussion group. We're realizing that papers like this aren't really seen by anybody who doesn't have subscription publication, not an inexpensive publication. And probably at least half our audience won't see this paper unless they deliberately go digging for it, because, as I say, hepatology is not a cheap subscription to get. So as you walk us through it, please keep in mind that we need to give enough detail so that folks who will not have an opportunity to read the paper unless you motivate them are so motivated to do so by what you have to say. I know you're really good at that, so I'm not worried about your rising to the standard. I just want to make sure you had it before we got started. And with that, my friend, the floor is yours.
Mazen Noureddin.
Thanks a lot, Roger, for picking this paper to talk about. It's actually called MASEF, which stands for the Metabolomics-Advanced Steatohepatitis Fibrosis score.
Okay, so the A is a short A, not a long A. Okay, I stand corrected. MASEF. Go ahead.
We're in an era of figuring out names and nomenclature, so we're straightening things out. We have MASEF, this is MASEF. So let me start with this. I think in the hepatology world of MASLD, we continue to look for the hemoglobin A1C. And I'm not trying to claim this is the hemoglobin A1C of MASLD or MASH, but it's a step. And there are other steps mentioned. I'll mention them. But to start with, this work actually goes back many, many years. It just makes me feel old and how long things take to get to a final product and how actually thoughtful research is. So I want to give the biggest credit to actually for this metabolic work, and especially in the field of MASLD, previously NAFLD, to Professor Jose Mateo in Spain, very well known in basic science and liver, and has contributed a lot to the field, especially in the glutathione and SAMe cycle, and more recently has done work in the metabolic field. Also his associate Rebecca Mayo and Cristina Alonso, they have done a lot of work. So this is how the story started. They were interested in metabolomics, and they have the techniques, including mass spectroscopy and NMR, which measure metabolomics in urine. And there were previous works published from this group, and we collaborated with them, myself and Arun Sanyan and many others on their work. So some of that work that came also that people may have not paid attention to is this test ability to distinguish between normal liver and MASLD or NAFLD overall. And that paper led to area under the curve of 0.8 plus something. And then to distinguish between NAFLD itself or MASLD and NASH or MASH, and that area under the curve was around 0.8. Then with the evolving field of MASH and risk stratification, when we found that MASH and F2 is the group that is of interest for clinical trials. And the reason why is because they have correlation with morbidity and mortality. We moved forward and created this score. This score is basically to identify MASH and F2 and higher. But what I'm trying to say is through this metabolomic spectrum that they have created, and as I mentioned, the test will become available in the US soon, maybe within this year or early next year, and CMS approved with its pricing. The report output will give you if the patient has MASLD or not, NASH or not, and NASH, MASLD and F2 or not. And you'll see it on a kind of colorful traffic light kind of spectrum. So going to the MASEF score. So this is an international effort, actually. It's one of the most diverse cohorts. And we have multiple co-authors who are lead authors in the field, including, I'll give you examples, and I'm sorry if I'm going to forget anyone. Marco Arisi from South America, Ken Cusi. We have Manuel Romero Gomez from Spain, Professor Javier Crespo from Spain. From the US, we have Arun Sanyal, myself, Stephen Harrison. We have Tatiana Kushner as well. From the UK, we have Quentin Ensti and many others. And everyone contributed to this sample. So the sample was, the testing cohort was almost 800 people, or 790, and the validation was 560 plus something. And the test compared the MASEF, which is again serum-based test that test MASH and F2 and higher versus not, to the FAST score. We also completed with FIB4 and NAFLD fibrosis score and many others, and transient elastography by itself, and it turned to be better, or at least equivalent, so to be more accurate. So MASEF consisted of 12 lipids, BMI, ALT, and AST, and did very well in the testing cohort of area under the curve in the high 0.7s, as well as in the validation cohort.
Jörn Schattenberg.
Mazen, you mentioned the cohorts are unique and very diverse. Before you come to the accuracy and some of the test characteristics, I realize you used a large derivation and validation cohort, and that's also derived from all these different centers, which are all referral centers. Is that correct? Or you have some more, I believe Stephen has some networks where there's more of a broader access to patient samples, maybe? Can you give a little bit more insight and background?
Well, actually, we did not use Stephen's cohort. The US cohorts were from my previous place at Cedars-Sinai, as well as VCU and Mount Sinai. The cohorts were mostly tertiary care centers, but many places in Spain and Chile and Mexico were also tertiary care center, but they were more liberal in performing liver biopsy.
I agree. They're known for that. I agree. They have a broader and a different spectrum. So one of the strengths looking from the outside is that you have from the two continents patients, no Asians, if I'm taken correctly. But still, I think a pretty broad spectrum of liver disease here. And referring systems.
Yeah, and another important point that in the, I guess, the testing cohort or development cohort, whatever you want to call it, we did not include F4 intentionally because, as you know, if you're looking for F2 and higher, if you include F4s, the area under the curve will improve because you have like a wider range and the AUC will perform better. So in the testing cohort, the area under the curve came as 0.76. And in the testing cohort, in the validation cohort, the MASEF performed as 0.79, and importantly, there was head-to-head comparison with the FAST score that performed as 0.74. It was not statistically significant, but numerically, many things of the MASEF score compared to the FAST were numerically better, like such as sensitivity was 0.79 versus the FAST was 0.59. I think the most important aspect of this paper is table 5. Currently, as you know, with the AGA, ASLD, and EASL algorithm, you do FIB4 and then they direct you toward ELF or transient elastography. Well, the problem with ELF, it doesn't tell you NASH at all. It doesn't tell you NASH and F2 and higher. It's prognostic tests for those that they're going to progress to cirrhosis and those they're going to progress to decompensation. But MASEF is NASH and F2 and higher. So this is what the test did. Again, what we did is we went to the AGA and ASLD and EASL and we said, okay, let's do the same. Instead of FIB4 followed by transient elastography or even FAST, we did these various comparisons. Let's compare FIB4, transient elastography, including the FAST, with FIB4 followed by MASEF. And the good news is, again, I will point people to table 5, that the algorithm starting with FIB4 followed by MASEF did similar by p-value to the FIB4 followed by transient elastography. Indeed, if you look at the numbers, there were many other numbers that numerically was better for MASEF. But what that means is the following. Let me give you first numbers. If you look at the FIB4 followed by transient elastography compared to FIB4 followed by MASEF, the FIB4 MASEF accuracy was 71 or 72% compared to 69% FIB4 by transient elastography. Sensitivity was higher, 61% for the MASEF pathway compared to FibroScan pathway of 54%. Specificity was similar, so as PPV and PPV, both MPV and PPV. And the indeterminate zone were 16 and 20%, not statistically significant. So here you have the first time I think I see it in NIT's paper that you're testing the new algorithm using FIB4 followed by imaging that requires referral and patient fasting compared to a test that can be another blood test, which is still sent out, but it's probably more convenient, and they perform similarly. So one of the suggestions we have, maybe this needs to be looked at in the future as current of pathways for more convenience.
And now, back to Roger.
We hope you've enjoyed this recording. If you have any questions or comments about the content of this conversation or the entire episode, please put them in the review section of the page from which you downloaded the conversation, or send an email to questions@surfingnash.com. We'll be back next week with coverage of Paris NASH later in the week, quite possibly a preview on Wednesday. Jörn Schattenberg and I will be together in Paris with a cast of friends and colleagues. Louise will be in Australia. Until then, stay safe, surf on. If you're in the Northern Hemisphere, enjoy this last long weekend of summer, and we'll see you next week.